Hello, Integrated 2. We're going to be talking about 3-2 similar polygons. So I've already written out the corresponding angles. So angle A corresponds to W, B to X, C to Y, D to Z. And so all of these are congruent. All of the angles are going to be congruent. Equal, but they're equal, but it's not equal. They are congruent, which means they have the same value, which kind of means equal, but it doesn't. And we can talk about that in a different video. So these are all have the same measurement. So these are all congruent to each other. So I could have said, hey, this is angle BAD instead of angle A. But looking at it, there's no other angle that can be associated with angle A right here. So I can simplify it a little bit and say, hey, this is angle A instead of angle BAD or DAB. So now we're going to compare these. Now we're going to make some proportions. Now we can say, hey, this is going to be the bottom and this is going to be the top. Why? It doesn't matter. We could flip them. It doesn't matter. So if I make this the bottom, I can say, hey, look, I'm going to write each of the sides, AB, WX. And I'm just going to write them out. Now you'll notice, like AB, WX, you're going to notice that, hey, each side I put, each of the vertices, I'm going to write the corresponding one. So if I say BC, B is to X as C is to Y. It's like an English, it's like, I remember this doing this in English. Like, all right, apple is to fruit as, let's say, celery is to vegetable. So in these cases, hey, we are creating proportions. And let's say DA now. All right, let's continue. So those are all the proportions and the congruent angles, congruent corresponding angles. All right, let's go on. Determine whether each pair of figures is similar. Okay, so first up, we have to make sure that they have the same angles. 90. So let's look at this. Here's 90. Here's 90. We're good. Here's 49. Here's 48. Here's 42. Okay, right now, it's not. We know it's not because the angles are not the same, so it doesn't have the same shape. Since, well, let's move this up. Since triangle, now let's make sure we write this. Since triangle ZWY, so we're going to go from Z to WY, does not have the same angles as triangle K. Let's see, which one would be in the smaller one? It was Z to the smaller, so ZW, so that'd be KML. The two triangles do not have the same shape, so they are not similar. So basically we see, do they have the same angles? We don't even have to see, hey, are these proportional? We're going to put this over this. We're going to see that 6.4 over 11 is equal to, let's see, what's the next one? The next, like the smallest angle. This one is 7.4. Oh, but that was on the bottom. The larger one. So 11 was on the bottom, so 7.4 should be on the bottom. And then let's go to the smaller angle right here. That would be this one, 4. Like, I already know right now, it's not similar because the angles are not the same, so it doesn't make a same shape. So, therefore, I'm not going to go through the hassle of, hey, are these equivalent fractions? I'm just not going to do it because I don't need to, because they are not the same shape, because they don't have the same angles. Let's go on. So, number 9. All right, so I know that these rectangles have the same angles. However, like, hey, what if we had a square? You know, and this was 1 by 1 by 1. Well, if I compare a square to a rectangle, technically the angles are the same, but they're not going to have the same shape because one's going to be longer than the other one. The other one is like equal all the way around. The other one is longer going one way. So that's why we do a quick check. The first check is, do they have the same angles? So if we look right here, we're like, hey, look, 90, 90, 90, 90, 90, 90, 90, 90. So all the angles are done. So now we can write this out. We're like, angles, check. Now we check the proportion. Now, I'm going to check the long side to the long side. So let's make the larger one be on top this time. 10 over 4. Does that equal, erase that, question mark. I'm trying to make a question. Does that equal 8 over 2? Well, let's see. What's 10 over 4? Let's divide by 2. And let's divide this by 2. Let's divide this by 2. And divide this by 2. Okay, well, it looks like it's not, because these should be the same. The proportions should be the same. Like, hey, look, if from here to here is times 4, hey, there's going to be times 4 as big. Well, then from here to here should be times 4 as big. But it's not. It doesn't equal 16. Like, this is equal to 8. Times 4 bigger, 8. Times 4 bigger, 16. Doesn't equal. So we can tell right now that, hey, look, this is not a scale factor. This is not. These are not similar figures. They can't be. Because although they have the same angles, the sides are not proportional to each other. One is longer. This is 4 times bigger. This is less than 4 times bigger. Let's go on. All right. We're going to be talking about, what is this right here? Get out of here. There we go. So each pair of polygons is similar. Okay, so we're going to say they're similar. Find the value of x. Okay, well, here we go. We understand that, hey, look, we can make this compare to this to this. So we're going to compare, let's say this is going to be our top. Let's say this is going to be our bottom. So we know that, like, looking at this, we're like, all right, across. So across from the double angle. So this guy is congruent to this guy. So I know when I'm comparing sides, I compare this side to this side. And I know this is going to be the top right here because it's above these two angles right here. Hey, look, this is above 2 angles. This one's on top. So I have to make sure that when I'm reading this, that I understand. So I know that if I write this out, we have quadrilateral P, let's go PBSC is going to be similar to quadrilateral. Well, let's see. The single one is T, goes up H, J, and R. So let's make this go on top. So top, bottom. 2 over 3 is equal to, all right, well, this is on top, x plus 3, and then 2x plus 2. Well, I need to get rid of this right here. So what I can do is I can do the cross product, or I can do the simple multiply equations right here. So I want to get rid of this guy on the bottom. So how do I get rid of this guy? Well, he's dividing. So I'm going to multiply by 2x plus 2. I'm also going to multiply by 3 to get rid of this guy as well. So I'm going to multiply this guy by 3 times 2x plus 2. Doing that will cancel out these two, and this will cancel out this. So I'm going to be left with 2x plus 2 times 2, and I'm going to be left with x plus 3 times 3. But looking at this, we see that, hey, there's a little, this looks like this thing called the butterfly method. This times this, this times this. We just actually proved it with some math right here. So when I multiply these two things, I get 4x plus 4 is equal to 3 times that, 3x plus 3. Now we just need to solve for x. Get x slowly by itself. So move x's to one side. X plus 4 is equal to 3. And then move the whatever's not x away. And we get x is equal to negative 1. There we go. That's it. The problem with this is we're going to have to learn the butterfly method or just simply multiplying to get rid of any fractions, any denominators in a fraction. All right, let's go on to the last one. Nayeli's rectangular lawn has a perimeter of 126 meters. Okay, well, what this is asking us to do is let's draw it. So I know this is my length and this is my width. So the perimeter is equal to 2 times the length plus 2 times the width. And so I know that's equal to 126 meters. Okay. The ratio of the length of the lawn to the width of the lawn, so the lawn to the width is equal to 5/2. What is the width of Nayeli's lawn? Let's give you a few seconds to think of an action plan. All right, so let's continue. So we're going to actually isolate for one of the variables here and plug it in for the other one. So what we're going to do is we're going to get rid of this w. So what's the opposite of divide by w? Well, it's going to be times w on both sides. So when I do that, I'm going to get L is equal to w times 5, 5w, divided by 2. Now that we've isolated, we can substitute that value into the other one. So I know that the perimeter is going to equal 2 times L. Well, L is equal to this right here. So instead of L, I'm going to put 2 times 5w divided by 2 plus 2w. So I know that's equal to 126 meters. So now, let's get rid of this perimeter right here. 2 divided by 2 cancels out. 5w plus 2w equals 126. So 7w is equal to 126. Using my handy-dandy calculator, I'm going to divide 126 by 7. Well, 126 divided by 7 is 18. How do we get that? Well, I used a calculator. I'll be honest. I'm not going to do that in my head. So W equals 18 meters. Now, I can plug it into either one. It doesn't matter. I mean, sure, why don't we put it into L is equal to 5W over 2. So now I go L is equal to 5W over 2. L is equal to 5. What's W? 18 meters. Okay, well, 18 meters. And so now I can divide by 2, get 9 meters. I have this 5 right here is equal to the L. 5 times 9 is 45 meters is equal to the length. So what is the width of Nayeli's lawn? Oh, I didn't have to find the length. That was it. The width is 18 meters. Well, I figured out the length, but it doesn't. Sometimes, we can do extra work and it doesn't do anything for us. All right, guys. That's it for 3-2 Similar Polygons. And I'll see you next week when we jump into 3-3. Bye, everybody.